Welcome to SilviCast, the podcast about all things silviculture. My name is Greg Edge.
And I'm Brad Hutnick.
And we are both silviculturists with Wisconsin DNR Division of Forestry and your host for today's show. Brad, I'm not so sure about this idea.
What do you mean? It's gold, Greg. It's gold. What forester wouldn't want the convenience of a 24/7 silviculture hotline?
Well, it's sort of a niche thing, don't you think? You really think there's people out there that are in such dire need of silviculture advice that they need a 24/7 hotline?
Of course there are, Greg. You'll see. Bars get out 2 a.m. People will be calling then. People wake up early. You know, foresters, they get up all hours of the night to get their work done. It's all set up and advertised. Don't worry, the phone is going to ring off the hook.
Mm.
See, our first caller. Silviculture Hotline.
Hi, I've got a 1928 King Richard sterling silver place setting. It's lovely. It was my grandma's. I've been keeping it in the china hutch, but it's really gotten tarnished. Is it okay to clean that with an SOS pad?
What? No, I'm sorry. This is the Silviculture Hotline.
Yeah, I know. Silver culture. Thanks for your help.
That went well, Brad, don't you think?
Hey. Rome wasn't built in a day. We're going to make this work. Silviculture Hotline.
Oh, man, am I glad I reached you guys. I don't know what I'm going to do. My boss is going to freak.
It's okay. It's okay. You've reached the right place, and we're here for you. So what's the problem?
Well, I just planted 10,000 containerized white oak this spring. And when I went out there to do the survival checks, half the trees were eaten by those hoofed locusts. In 1 month, can you believe it? You know what those seedlings cost us? There were 4 of them swamp donkeys eaten away while I was doing a survey, popping seedlings like they were Tic Tacs.
Well, deer browse is a tough one. Have you tried the usual methods? Have you gone out with repellents, fencing, deer tubes, anything like that?
I don't have time to set up a fence. Brad, I see you're going to have your hands full with this hotline. Maybe you should suggest the caller listen to today's episode of SilviCast, because today we're going to be talking with 2 colleagues who know an awful lot about deer forest ecology and impacts. And those are Alex Royo, research ecologist with the U.S. Forest Service's Northern Research Station, and our own Amanda McGraw, research scientist with Wisconsin DNR.
I think that's good, Greg. So, sir, hold on a second. I might have an answer for you. This season of SilviCast is brought to you by the Nelson Paint Company, McCoy Construction and Forestry, and the Family Forest Carbon Program. You make the SilviCast world go round, so thank you. Amanda McGraw and Alex Royo, welcome to SilviCast. For our listeners, could you tell us briefly who you are, where you are, and what you do?
Yeah, I'll go first. Thanks for having me today, guys. My name's Amanda McGraw, like Brad mentioned, and I work for the Wisconsin Department of Natural Resources in the Forest Economics and Ecology section, along with Brad and Greg in the Division of Forestry, where I serve as the Forest Ecology Management Research Scientist, which is a mouthful.
Yep.
The research scientist, good enough, probably.
Yep, and also one of our favorite people. So just so you know.
Hey, you guys are one of my favorite peoples too.
Yeah. Oh, now you're just saying that because we said it, but it's okay. It's okay.
So I'm based out of Rhinelander, Wisconsin, and I work throughout the state on a wide variety of projects ranging from the use of silviculture to promote old growth characteristics in our second growth northern hardwood stands to projects like identifying impacts and researching mitigation techniques for new and emerging forest pests. But I would say one of the through lines of many of the projects that I work on is deer and their impacts on our northern forests.
And I'll go ahead and introduce myself. Hello, good afternoon, folks. I'm Alex Royo, and I work for the Research and Development Branch of the USDA Forest Service. For those who don't know, the USDA Research and Development Branch is broken up into a number of stations geographically. And I work specifically within the Northern Research Station. This is about 360 folks total. About 110 of them are scientists, and we're dispersed in this 20-state region that one could roughly say is bounded by Maine, working out west to Minnesota, then Missouri, and then Maryland.
Hmm.
Within this organization, I work as a research ecologist. I'm stationed in northwestern Pennsylvania. We're kind of right here in the middle of the Allegheny National Forest that I can see as I look out my window. And as far as what I work on, some of my colleagues have made jokes that I'm the, what do they call it, jack of all trades, master of none. I work on a number of different things, but perhaps a unifying theme across my research is that I'm always trying to determine what are the mechanisms that underpin vegetation diversity? How do we maintain vegetation biodiversity? And how we can take that knowledge and then translate it into practical forest management guidelines. And so deer, obviously, and deer browsing are one of those factors.
Well, and what got you guys interested in forests and ecology in general?
Well, I'll just follow up with my introduction. I'm from the Republic of Panama. I was born and raised in Central America. And I was very lucky to grow up in a spot in Panama that was very, very close to the jungles. Literally within a block or two of my house was a national monument, Cerro Ancon National Monument. And so I would spend many of my afternoons just playing in the woods, being a kid in the woods, right? Playing soldier, building forts, whatever. So I was always in that jungle. And then on top of that, my house was about 2 blocks away from the Smithsonian Tropical Research Institute complex. The Smithsonian Tropical Research Institute is arguably the premier tropical ecology research institution in the planet. And they have a library and they have air conditioning. So a lot of times in the afternoons, if I needed to cool down and I needed resources, encyclopedias or whatever, I would walk up the hill and just hang out in this research atmosphere surrounded by folks doing research. So perhaps I was always destined to be an ecologist because I was playing in the woods and hanging out with researchers, even as a kid. I actually did my PhD research out of the University of Pittsburgh, and initially it was focused on tropical ecology. And I actually had the good fortune of doing some work right there where I hung out as a kid at the STRI. But, life takes a lot of twists and turns, it's never a straight line. And I ended up working for the U.S. Forest Service here in Pennsylvania on temperate forests.
Oh.
Alex, you could say when people ask you, how did you get into your career? You could just say air conditioning.
Yes. I always mention the air conditioning because it's true. It can get oppressively hot and humid in the tropics.
Yeah.
How about you, Amanda?
I didn't grow up in the tropics like Alex. I grew up on the shores of Lake of the Woods in northern Minnesota. So not the tropics, but also grew up very close to nature, spending my days, in the forests or biking to the beach on Lake of the Woods and swimming or fishing. My family is a huge outdoors family, so we spent most of our free time hunting or fishing or just exploring that part of our natural world. And I really fell in love with that landscape of northern forests and lakes and rivers that we have in this region. And so I was just thinking, my mom recently, in the last few years, found a little report I wrote in second grade. And it was like what I want to do when I grow up. And in second grade, I have no memory of this, but apparently I wrote, I want to study wolves because I want to know something no one else knows. And so I would say my interest in ecology started from a very young age and definitely carried through into my academic career where I studied wildlife ecology at the University of Wisconsin in Madison. And then when I earned my master's and PhD at the University of Minnesota, where I studied moose and deer habitat use in northern Minnesota. And then I came to the Wisconsin DNR in 2016. And when an opportunity arose to jump into the role of the forest ecology research scientist in 2020, I jumped at that because I've always had that interest in forests and wildlife interactions. And this seemed like just a really great opportunity to continue to explore that interest.
Nice area up there at Lake of the Woods.
Yeah, it's beautiful.
And Greg, that does continue the theme that we've heard from a lot of our guests, that it wasn't like late in life or like it was early on, you kind of had that appreciation that kind of carried through the rest of your life.
Yeah, that's kind of been the theme on everyone,
Yeah.
which is really interesting. So, Alex and Amanda, today we brought you here to discuss, by popular demand,
Oh boy.
the topic of deer, right, Brad? Popular demand.
Well, yeah, especially for those playing at home with our drinking game, as deer is the word that you, and we should have like a warning label on this episode too. If you're doing that, like lower the proof or just go to beer or something, because this episode will take you down.
Yeah, no shots per deer mentioned.
Yeah,
That's right.
yeah.
That's right.
That will not be sustainable.
No.
Sorry.
Yep.
So today we wanted to have a conversation with the two of you on what we have learned about how deer impact our forests, and then where the science is going today in terms of how can we take that knowledge and help it with our management. So that's kind of the theme of today. And both of you have worked extensively in forest and deer interactions. So I think this is going to be a great conversation about kind of where we're at. Maybe a good place to start this whole conversation would be with a little Deer Biology 101, just so we're all on kind of the same level.
And that's cool. I think, Greg, there's always that story about Vince Lombardi holding up a football at the beginning of camp and saying, "This is a football," because he wanted to go back to the very beginnings. And so we're going to start like that here. So we're all familiar with deer. What do deer eat? Like, we're foresters, we see them out all the time, but there are certain things we know they're not carnivorous, right? But outside of that, do they eat anything, or is it a little more restricted?
Yeah, I mean, they might be carnivorous on accident.
Yeah,
but certainly no, we wouldn't consider them a carnivore. A lot of folks would consider them toward the end of the spectrum that we would call like a generalist herbivore. So they eat a wide variety of plant material, and that ranges from agricultural crops, I think we all know that, to herbaceous plants like trillium, to young trees, to hard mass like acorns, and then at different times of year when they're available, they'll even forage on aquatic vegetation and things like mushrooms, or if you're in the right part of the country, they'll eat prickly pear cactus. So really, really wide, diverse diet that deer have. But they are a class of herbivore that we would consider to be concentrate selectors as well. And that means that while they will eat a huge wide variety of plants, they are selective in the choices they're making when they're eating. And so they have preferences. They do like certain plants more than others, and they will selectively eat parts of plants more than other parts of plants. So you can think of like the terminal stem rather than lateral would be a preferred part of a plant that a deer will choose to eat first if available. So wide variety, and selective in that variety that they choose.
You'd say within deer, is there something that would make a certain population or certain deer more picky than others, or in particular places?
Oh, sure. I think we'll talk a lot about this as we get into the podcast, but definitely their selection or their pickiness has a lot to do with what's available to them on that part of the landscape, whether it's a regionally available or if it's a small pocket of availability within a region of certain foods. That will definitely influence their selectivity in a certain area.
How much does a deer normally eat? Like, say, on a day or on some kind of basis like that?
Yeah, that's a good question. So on average, a healthy deer is going to eat between 6 and 8% of its body weight each day. And in Wisconsin, the average buck will weigh about 150 pounds. So any of you really quick at math? You know how many pounds of food? It comes out to between 9 and 12 pounds of plant material per day for the average deer in our region.
Huh.
Yeah, so that's a lot. To put that into context, I went back into some of the old research that I've done here in Wisconsin and looked at values that we put together where we clipped what we called browsable biomass on a stem of different species of seedlings and saplings. And so for, say, an average young white oak that's within that browse range that deer can reach, so say from like 1 to 6 feet or so, there's an average of about 14 grams of dry weight of browsable material if you think about summer browsing, like leaf material. So that's probably double that in the fresh weight. So that equates to about 175 individual white oak stems. If the deer were to remove all browsable biomass, that's how many stems of white oak it would take if that's all it ate in a day.
Oh, that's our depressing fact for the day right there, huh?
Yeah. Yes.
Yeah.
I like to put it in the context of like how many stems it is, because it's a big number. It takes a lot to feed deer.
Amanda, you had already alluded to this, but deer are preferential browsers on material. And we always talk about kind of browse preference in terms of the seedlings that we plant or try to grow, but it always seems to be quite variable. Why is it so difficult to determine what that browse preference is?
It's difficult for a number of reasons. So, like I mentioned, it really depends on what's available to those animals, both at, the patch where they're at, but in the broader landscape. And their diet will shift throughout the year and across seasons and even within seasons. And so if you think about when they're grazing or browsing on spring ephemerals, often they will remove the entire above ground biomass of that plant. And so once they've removed it, you can't even see that they were there and have eaten it. So that's really difficult. In terms of woody stems and removing leaf material and things like that, throughout the season, you might have like refoliation events that kind of mask their material that they've removed earlier in the year. And so, those kinds of things really kind of muddy the waters in terms of being able to really nail down what they're preferring all the time.
I mean, really, it's one of those $1 million questions, right? Folks, way before I was even employed here, since time immemorial, have been asking, what's preferred over what? Can you tell me the ranking? Can you tell me the ranking? And unfortunately, it's not a satisfying answer, but unfortunately, the answer is, it just depends. So preferences in general, or browse pressure, it really depends on a range of factors, and these factors vary. They vary all the way from the individual plant scale all the way up to the plot scale, and then even beyond that to the landscape scale. And so if you think about a deer, its sort of core problem it has to do is maximize nutritional needs in the least amount of time. So it's always looking to kind of get at this efficiency factor. So if you think about it even from a plant scale, right? Plant species and even individuals within a plant species, they'll differ greatly in their nutritional value. They'll differ in their chemical composition. They can differ in physical properties and such. So some species, say like pin cherry, Prunus pennsylvanica, that's a species that's highly digestible. It's highly nutritious. And so it tends to be much more preferred, higher on that ranking, if you will. Other species like American beech, not so much. Yet again, some other species like the spruces, the pines, a lot of these conifers will have higher concentrations of terpenes, those aromatic compounds that give conifers that delicious scent. Well, those things deter digestibility. They're compounds that can actually reduce efficiency, if you will. And so they tend to fall further down on the palatability scale. Plants that have physical protection, like spines, acacias, etc. So it's not really easy to just say, like, here's the ranking of preference. There are all sorts of things that affect preference, even within a species, not to mention the complexity that's added when you think about the neighborhood those plants exist in, and then the landscapes. And we can chat about all of these things if you want.
I'd also like to chime in that often when we ask, or when I get asked the question, what do deer prefer? What we're really talking about is what are they selecting? Preference and selection are two different things, but we kind of use those terms interchangeably. And I think that kind of can add to the frustration sometimes when we say we can't say what a deer prefers here. And I have a great analogy, since we've talked already about drinking games and beer. If you think about preference this way, you walk into the world's biggest beer store, it's got every style available. So what are you going to do if you want to pick out a beer? You're going to go to your favorite style of beer and you're going to get that beer. But if that store is out of that style of beer, then you probably go to your next favorite beer, right? And that's exactly what's going on with deer when they're trying to, make their selection for food on that landscape, is figuring out, what's available to them and taking into account everything Alex just mentioned in terms of not only availability, but palatability and digestibility.
Yeah. So taking that beer analogy, Amanda, a little further, if a deer learns that they should eat something, so let's say Brad taught me that this beer is really good, and I've learned to drink that one. So then do I go back to that? Is that is preference also can be a learned behavior?
I don't know if I know the answer to that in terms of deer. I mean, you can maybe if you want to talk about hostas in your backyard and they've never seen one before, but then they take a little bite out of it and they're like, oh, this is really good. And then they keep coming back. I can imagine how that would be learned.
Would that be that difference between selection and preference too? Like you might learn to select it. Like if we see Greg with a Busch Light in his hand using the beer, so we know he selected it, but that may not be his preferred beer.
Oh,
correct.
Yeah,
it was just what was available.
What was available
sale,
at the
right?
party.
Yep. All right.
Yeah. Okay.
You gotta drink something, right?
I think we've taken this beer analogy far enough. I'm sorry. I digress.
So we've taken the beer analogy far enough, but I'm gonna keep on this road,
there we go.
a little bit longer, right? So
Yep.
so that beer analogy is from the consumer standpoint, right? So the deer or the individual, Brad, Greg. But to go back to what I was saying about how plants themselves can differ, I'll give you another adult beverage analogy, right? So I've been drinking a lot less beer and drinking a lot more bourbon, right? And so we think that if you buy a specific mash bill, a specific recipe from a specific distiller, it's going to be the same flavor and aroma profile time and time and time and time again. But if you follow bourbon, you've noticed that there's been this trend of single barrel selections, right? And they're marketing these single barrel selections because the reality is, even if you have the same recipe from the same distiller, depending on which barrel it's placed in, depending on which rick house within their complex it's placed in, depending on which position within the rick house, whether it's low, whether it's high, whether it's close to a wall, all these temperature variations affect the maturation process, aging process, and then of course how old it's aged. All of these things, even for the same recipe from the same distiller, are going to result in a continuum of flavor and aroma profiles. And so it's the exact same thing with plants. We want to think of plants as having this value, but in fact, depending on where that plant is growing, high light, low light, high nitrogen, low nitrogen, etc., these competitors, those competitors, that milieu, that context is going to shift or vary how chemically attractive, how nutritious it is, how digestible it is. So there's a continuum here at play. It makes it very complex.
Yeah. So we get with a bourbon, we get to read the label. We get to, and they'll never tell us like the rickhouse, all that, but we kind of know a little bit more about it. But how would deer, how can they tell that difference? Greg, we always hear about like when we plant seedlings out that have been in the nursery in these high nutrient environments, that deer will prefer those when we put them out. But how would they tell that? What would be the mechanism behind that?
There could be some kind of chemical signal that the deer are able to pick up on. It could be random chance that they happen upon this group and they're munching their way into the stand and they're like, oh, these ones taste a lot better than those ones over there, so we're just going to stay here. So it could be a combination of those two things.
Yeah. Okay.
That's my guess.
The bourbon thing is, it all tastes the same to me personally, so I can't relate. But Brad and Alex, I'm sure will debate fiercely with me.
Yeah, great. We'll talk later about that, Greg.
So that kind of leads into, this is a related question, and that's, what have we learned about deer overabundance in our forests and the impact on those plants? And I think, Amanda, you also already mentioned some plants that get targeted heavily. So are there particular plants that we see in our eastern forests that are heavily impacted by deer?
Yeah, I can talk about some classic examples of some species that in the eastern forest that are consistently browsed or preferred by deer. Like we said, it's difficult to define preference for a lot of species, but there are certain species that we know are pretty consistently preferred by deer. One of those is the northern white cedar. That's preferred pretty much across the deer range in the Midwest and the Northeast and into Canada. It's highly preferred in the winter, especially. And a lot of this is to do with how deer act in the winter in this region. We have a highly seasonal environment, and in areas with lots of deep snow cover, cold winters, deer yard up, and they often are yarding up in these conifer stands that are predominantly cedar or hemlock in some areas. That's another good example of a tree species that's heavily preferred across deer range, the region we're talking about. A lot of times these plants are considered especially vulnerable because they tend to be a little bit slow growing. And so they kind of hang out where deer can reach them for longer. And when deer are all congregated in these coniferous stands in the winter, there's not much else for them to eat. And so you see there's very little to select from, very little available diversity in those wintertime stands. And so you see kind of a double whammy of them being targeted because they're there longer, and then having more deer congregated with less available to them. So those are two classic examples of trees throughout the region. There are other examples of, say, shrubs like the Canada yew. That's heavily targeted by deer. It's highly preferred across its range. And it's actually nearly eliminated from the landscape in areas where we have abundant deer populations. A really kind of interesting natural experiment, if you will, about Canada yew and deer interactions can be found in our own Apostle Islands, where we have islands that have sustained pretty high abundant deer populations for a number of years, and those islands are essentially devoid of yew. And then partway down the spectrum where we have mid to low abundances of deer, you have some yew still available, not nearly as much as on what you have on the deer-free islands where yew is still highly abundant. So you kind of see how that plays out with different densities of deer in our own fossil islands. And then as an example of, say, an herbaceous plant, trillium is, I think, the classic example that deer love to eat. We have a lot of documented impacts on trillium, from removal of populations to impacting flowering and other demographics and even height of the plants.
I'm curious, and this would be for both of you, where do you think hemlock fits in that? Because we're probably going to start a fist fight somewhere with ecologists or biologists about this, because I know some would say, deer are only selecting for it in certain situations, and I would say, no, they really prefer it. Where would you come out on that?
I think it's both.
Yeah,
I think it's context dependent. Like, you can see stands where deer just totally hammer the hemlock, and then there are others where it's doing just fine. And so it's really depends on that person's experience and where they're working.
Here on the Allegheny Plateau, it's not high on the preference scale, but it's pretty much wiped out because, again, in the wintertime, it's one of the only things that's green and available to deer. And we've seen that time and time again in our old growth remnants. Hemlock recruitment has essentially vanished for much of the 20th century. We're seeing some hemlock recruitment now. That deer numbers are lower across the landscape on average, but throughout much of the 20th century, hemlock recruitment was nil.
Yeah, here I would agree with Amanda. It's like, depends on where you're at. Sometimes it's heavily impacted, and other times it looks just fine. You have a lot of regen. It's quite variable.
And so if we were on that scale between preference and selection, it's not to the far end like Canada yew, but it's not on the opposite end of things that's going to skip away from, right? Like, we don't want to eat those. And what would be some good examples of things that they definitely wouldn't eat?
Oh, well, one good example we would consider a starvation food, which is like, this is the food they eat when literally nothing else is available, would be balsam fir in our region. But that, again, is not across the board, because in a place like Anacostia Island in Quebec, Canada, deer survive off that in the winter. It is a survival food. But probably white spruce is a good example of something they just don't really touch.
Another examples are that come out in the literature a lot, and that I have examples with and research on is the ferns, hay-scented fern, for example, Pennsylvania sedge, Carex pennsylvanica. So, and that's an emergent pattern, of what have we learned from having, to use the term loosely, overabundant deer on the landscape for a long time is you do see these direct consumptive impacts over time. They start to shift composition of the forest understory. You start to have reduced abundance, reduced size, reduced survival, reduced reproductive output. Amanda mentioned of some of these more palatable or sensitive plant species, and in turn, some of these other species that are less palatable or less sensitive. They tend to increase on the landscape, and so it's not uncommon for at least for me to walk into the woods here and see acres and acres and acres as far as the eye can see of this understory that's dominated by hay-scented fern. It's very park-like. There's nothing in the mid-story at all, and then these gorgeous 100-year-old cherry stems, maple stems, etc. And that's really a legacy. What was almost a century of high deer densities and low carrying capacity on our landscape.
Is that also diagnostic maybe in northern hardwood stands with Pennsylvania sedge you mentioned?
Yes. Yeah.
So you would see those sort of carpets of Pennsylvania sedge with not much else in that understory.
Yeah, and there's work from Wisconsin that documents this. There's work from the vegetation of Wisconsin, Curtis's work.
Mm-hmm.
They found these stands back in the 50s that they surveyed, and here's the vegetation back then. And there's been researchers that have gone in, Don Waller and others have gone in half a century later and resurveyed those very same stands, and you can see these transformations almost. Where there are winners and there are losers in terms of the plant community, and one of the winners is Pennsylvania sedge, an unpreferred, low palatability, resilient plant species.
Alex, do we know how long those sort of legacy effects can last?
The short answer is decades, and there are a number of different legacy effects at play, but just those conditions can last decades. So I've worked here in Pennsylvania on the Kinsa Quality Deer Cooperative, and we could talk about that project later. But in that project, we've looked at lowered deer densities for 20 years, and there's been, in terms of overall plant species composition and change, it's been essentially static. Tree regeneration has improved, but overall plant community has been essentially static. If we go to New Zealand, it's not here, but if you go to New Zealand where they're introduced deer, there's been some really neat work by Hashir and Tanenzap, and they've monitored recovery or lack of recovery for 6 decades. 6 decades of reduced deer herds through targeted culling efforts, and tree regeneration is still very, very low, very, very sparse, and doesn't match up or approach what you would find inside a fence or in these reference conditions from decades ago. So legacy effects can last a long time.
So once those kind of understories are formed, even if the deer herd goes down, that still can be maintained in that, probably because there's very little browse material available. So anything that grows, right, they get.
Yeah. So think about that. Think about that condition. There was a term earlier Amanda used was double whammy, right? So if you kind of follow the timeline, let's say deer have shifted composition, right? Reduced regeneration, and all of a sudden you have a native plant, pen sedge or hay-scented fern, for example, that becomes essentially an invasive. It covers the understory. Now, even if you reduce deer or even eliminate deer, the light conditions underneath that canopy of fern or sedge are so low, that it's just so dark that most tree species have a hard time germinating and growing. It's just too dark for most of our mid-tolerant to intolerant plant species. On top of that is really a triple whammy, because underneath these dense covers of herbaceous layers or even shrub layers in other places, you actually even have increased seed and seedling predation, right? If you're a small mammal, you're a rodent, and you're out there foraging for seeds, would you rather forage out in the open where you're at risk of getting preyed upon by a hawk, or would you rather forage underneath that dense cover? You prefer to forage underneath that dense cover. And so it's really this triple whammy once you have this legacy effect in place. The seeds and seedlings are getting preyed on. If you can germinate, you have a hard time growing because it's really dark. And heck, if you can grow through that layer, you're one of the few items that's available for deer to hone in on and target. It's very hard to overcome those legacy layers.
Oftentimes when we're looking at forests or woodlots that have had cows in them, we'll see that elimination of those native species. And then you could tell like it would be really hard to recover because now you have to move things in. Is there a similar thing happening with deer as well?
Yeah, I would think yes. And I've done some work, not a lot, on the strength of these legacy effects. Some work that was recently published from some long-term exposures that we have here in the area. We do seem to get some recovery of the tree community because we have those adult trees in the canopy, right? And they're seeding every year, trying to get a single seedling. Remember, a mature tree only has to, even though it puts out thousands, tens of thousands, millions of seeds over a lifetime, it just needs one to grow and survive. And so the legacy effect for trees, I think, can be overcome much more rapidly. The legacy effect for herbs and shrubs is, I think, going to be much, much harder to overcome because if they're reduced to very, very low abundance, and some of these are obligate outcrossers, right? They need to cross-pollinate, and it's just very difficult to attract pollinators if you're rare. And if you attract that pollinator, for that pollinator to go to another individual, I think it becomes just a lot more challenging, Brad.
Yeah. Looking for continuing education credits? Check out the SilviCast webpage for more information. And now, back to our show.
Alex, you alluded to long-term deer enclosure studies that have happened out in the East. What have we learned from those in terms of deer densities? And here I'm curious about, like, is there an ideal number of deer to have in the forest, or is there thresholds of deer, like deer per square mile, where we know we start to see these kind of more severe impacts, or we know that tree regeneration is really problematic?
Yeah.
Do we have any idea of what those thresholds are?
The long-term work that I mentioned just a minute ago was exclosures, so fences that keep deer out.
Okay.
But you're absolutely right. Here in Pennsylvania, the lab that I work in before my time, in the decade of the 1980s, they ran a deer enclosure study, right? So they penned in deer for a full decade at different densities in a sort of dose response experiment to see what happened at different densities. And that's definitely a step forward to the exclosure work where you have 0 deer inside a fence and some unknown number of deer outside a fence. So in this enclosure work, there was a known deer gradient of 10, 20, 40, and 64 deer per square mile. They built these massive fences and then subdivided them into 4 pens. The pens were 64 acres and then the rest were 32 acres. And so by putting 1 deer in 64 acres, for example, that's the equivalent of 10 deer per square mile. 1 deer in half that area is the equivalent of 20 deer per square mile, and so on and so forth. So they did that. They ran that experiment for 10 years, from 1979, 80, all the way into 1990. The big takeaways were that, yes, same as we've been talking about, the species that are avoided by deer are generally avoided: less sensitive ferns, grasses, sedges, and also black cherry, Prunus serratina. These increased in abundance as deer densities ramped up. Conversely, blackberry, so rubus, the birch, red maple, basically almost all other tree species, declined in abundance as deer densities ramped up. Overall plant species richness was also declining as deer densities increased. And so really it became very difficult at those higher deer densities to regenerate a diverse mix of species. At those higher deer density pens, which ended up being on average 64 deer per square mile, you still were getting regeneration, but it was overwhelmingly dominated by one species. Black cherry comprised as much as 60% of the regenerating layer. Not really a desirable outcome from where we would stand if you're trying to practice sustainable forestry. Now, in terms of a density per se, is there a recommendation? The results of that work suggested that when you hit, in our forests with our mix of species under this experimental context, about 20 deer per square mile seemed to be a threshold, a recommendation. Above 20 deer per square mile, you started to see rapidly increasing declines in regeneration of a diverse mix of species. So that being said, and I think Amanda and I can talk more at this, that don't leave this podcast thinking 20 is a great number. It's a moving target. It depends. The number of deer that are appropriate for diverse regeneration or for biodiversity is going to shift tremendously depending on the context, on the landscape context that you find yourself in.
What's interesting to me on that is that must depend on like so many other factors, like just the forest cover type itself and how productive it is.
Absolutely.
It seems like some of those general patterns hold true, though, like you described in those higher deer levels, getting down to a single species of regeneration or, a very limited amount, and we see that across different cover types as we go into areas that we know have higher deer populations. The understories get more simplified in terms of the number and the diversity of species. And it may not be cherry in our case, but it could be ironwood, Brad, or something like that.
We've talked about this, Greg. We're driving around, we're in the car, we're kind of talking about and throwing things around. And you wrote a paper a while ago that talked about this idea of foodscapes. And so maybe just to start the ball rolling in that direction, what is a foodscape?
Before I describe what a foodscape is, I will say that what I just described from that deer enclosure study, there was a lesson learned from that.
Yeah.
We did have regeneration even at 64 deer per square mile, although it was dominated by black cherry. At that time, in the decade of the 80s, numbers of deer densities far lower than 64 deer per square mile were causing abject regeneration failures on the Allegheny Plateau in our Allegheny hardwoods, northern hardwoods type. And so then the question was, well, why? How come in this experiment over a decade, we're seeing some regeneration, mostly black cherry, but some under 64, but out across the landscape in real conditions, we're not seeing that. And so that caused us to step back and then look at the experiment itself and how that reflected reality. The experiment, which I didn't mention, the experiment not only penned in deer at different densities, but it also manipulated overstory conditions through harvesting. So each of these areas had 10% of it was clear cut, 30% of it was thinned, and then the remaining 60% was uncut. And so these deer were existing in a landscape, if you will, in an experimental landscape, in which as much as 40% of that area was capable of producing forage, the 10% clear cut, the 40% thinned. At that same time on the Allegheny Plateau, the numbers, those proportions were just 4% in clear cut on average and 13% under some type of shelter wood or thinning, so partial removal. And so in reality, the deer numbers that we had on the landscape were experiencing a condition where far less of the landscape was in this forage production capacity. And so this really led us to hone in on this idea of don't focus on deer density, focus on deer impact. And deer impact is driven by two dials. One of those dials is density. The more deer you have, the higher that impact is going to be on plant communities. The other dial, the other axis, is going to be the landscape itself, the foodscape that you talked about. And so what's the type, configuration, abundance, and even interspersion of different habitat patches throughout that landscape, and how much of that landscape is in patches that are capable of producing available forage for deer. And so that's why I use the term foodscape in the paper, but it really all ties back to that core concept of carrying capacity, right? So that's essentially what the foodscape is just a eye-catching phrase or eye-catching way of talking about carrying capacity.
Was there any results from those studies that determined how much of that forage-rich habitat, I'm assuming early successional
Yes, absolutely.
habitat, had an impact on, the regeneration within those areas?
Yeah, so we actually applied for a grant and ran a study for several years that we called the Foodscape Study or the Deer Impact Study. We had over 24 areas within northern Pennsylvania, northwestern Pennsylvania. Each one of those areas varied in its foodscape configuration. So some of those areas were on one end, where most of that landscape, a square mile landscape, was mature forest. And then there were other areas where the landscape or the foodscape had mature forest with some agricultural production, with some clear cuts and thinnings and maybe a right of way that was planted with early season grasses, et cetera. So a far richer foodscape. So we had a continuum in foodscapes or carrying capacity. In the dead center of each one of those areas, we had a shelterwood stand that we had a fenced and unfenced pair, right? So a fenced area and an unfenced area. And the difference in any plant metric, say cover, that you find within the fence and outside the fence, that's what we called impact, because all things being equal, right? If you're in the same stand and you're just a few meters apart, if there is 80% cover inside a fence of a plant and 20% cover outside a fence a few meters away, that difference we're going to assume is due to browsing, right? Because all other conditions are the same. And so what did we find? We found that over a number of years, in landscapes that had 20% or more of that landscape in forage-rich early successional habitats, the difference, the impact between the fenced and unfenced pairs was essentially nil. So you could obtain diverse regeneration and a bunch of other herbaceous species outside a fence to the same degree as it was located inside a fence when you reached about 20% of the landscape in forage production, because those deer basically had a number of other places to browse in and browse from. It was a very diverse buffet, if you will.
It's an interesting thing to think about. Just that arrangement of things in the landscape could impact like what's happening.
Absolutely. I think when we're considering like landscape level or foodscape level impacts of deer, it's really good to think about some of the things Alex just mentioned, like configuration. So adjacency, juxtaposition, size of the patch, how many patches, that all comes into play when we're trying to think about how deer are going to move across that landscape. Are they all going to get congregated in one giant patch that you created that maybe is 20% of the larger landscape, but it's only one, so that all the deer go there? Or you can create a bunch of, smaller disjunct patches throughout that landscape so that the deer are a little bit more diffuse across that landscape. Yeah. So I think it's essential to think about that configuration when we're talking landscape level impacts.
It makes our forestry management just that much more complex. It's like
it does.
It's like a game of Risk or something. You're trying to strategize across multiple stands through a landscape area.
And on top of that, Greg, not just multiple stands across the landscape, but then the timing. And this is where it gets even trickier, right? So let's just say 20% worked. It only worked for a few years under that specific context. But when you all of a sudden provide a lot of early successional habitat and forage, deer might have higher fawning rates, higher survival. And so deer density might go up, right? And so all of a sudden, those two dials on that deer impact are changing. And so all of a sudden, 20% might not be appropriate. You might need more because now you're carrying more deer because they've had more fawns and higher survival. And on top of that, forests are dynamic. That whatever you create for forage, these early successional forests are only early successional for a while.
Right.
After a decade or so, they become forage deserts, right? They become stem exclusion stands, pole stands. And so all of a sudden, that 20% of food or what have you, all of a sudden becomes 20% zero food. And so your deer impact should jump up. And that's one of the things we also saw from this foodscape study is this, the more important predictor of deer impact wasn't necessarily the proportion of early successional forest on the landscape, but rather pole stands or stem exclusion stands on the landscape. Where we had more and more stem exclusion stands, deer browsing was concentrated in those remaining few pockets of early successional forest, shelter woods, or clear cuts. And so you have to think about this in a dynamic fashion. Amanda and I were talking earlier, and we said, it's always a moving target. We can't tell you what preference is necessarily. We can't tell you a number of deer or a percent of the landscape, because each of these things is highly dynamic and shifting over time, which goes back to your introduction on how this is $1 million question and a drinking game.
Yeah.
It's just very hard to resolve.
Yeah, I think we've said deer about 200 times by now.
Yeah.
Good thing I'm drinking water.
Yeah.
That's right.
So, I mean, this really gets into the heart of what managers can do with this issue. And what I'm hearing you saying, we need to be thinking broader than the stand level. So we need to be thinking about that foodscape and the landscape, but also realizing that is always dynamic and always changing. So I'm wondering, as a forester, like, what do I do? What do I do? Do I keep certain proportions across that landscape? I mean, I can try to manage for age classes and a certain percentage. That's possible through scheduling. I guess what's a manager to do?
I think that's a really hard question to answer. But I think part of it is just that recognition that these are complex dynamic systems and that there is no end point that we're going to reach because the target's always moving. And so I think this is going to be a really general statement and maybe frustrating to some of your managers, is just we're going to constantly need to be measuring what's going on and then reacting to what we're seeing out there. It's kind of a constant iterative process that we're going to have to undertake, I think, to manage healthy forests with the deer populations we have. And so it's just a recognition that there is no end point where we've we've accomplished our goal and reached X many deer or have X many stems, because these systems are just too dynamic.
Yep. Yeah, just to follow up, I would say, your point of scheduling the harvesting so that you do have a sort of a constant input of early successional forage as these things start to age out over time is important, right? So managing the landscape on this continual fashion, this continual manner, if you can. And then, of course, the other end of the other dial itself is adaptive management of the deer population itself. Track the impact, monitor the impact, and if you see that it's ramping up, work with your game management agencies and court hunters and participation to try to bring those deer numbers down, right? So always trying to balance that habitat carrying capacity with the herd numbers, which is what we've done in that project that I mentioned earlier, the Kinzu Quality Deer Cooperative. And I know that the prior guest, Susan Stout, talked about that at length.
Yep. I like that idea of having multiple dials that you're kind of playing with. It's not just the deer numbers. There's other stuff with it. And we've talked about, Greg, this idea of landscape silviculture, where we're looking at the landscape to help us decide on what we're going to do at a local level. So I was just thinking, as you were talking about that, if I were a landowner and I had a landscape of pole stands around me and I'm getting ready to do a harvest, I might want to think twice. But you'd have to know that you had a landscape of pole timber around you in order to make that judgment.
Yeah, you might have to think twice, and if you think to go ahead and pull the trigger, then you probably have to consider a remediation technique like fencing.
Yeah. We didn't really intend with both of you to get into some of those mitigation measures like fencing and tree tubes and things like that. But I think that's a really good way to think about it is you're controlling that landscape and that foodscape, and you can recognize, just like you said, Brad, where you may have a difficulty. And so then you may need to kick in mitigation measures, and that's part of your strategy, right?
I'm imagining if I'm a forester listening to this, I go, well, how do I do that? Right. So we probably need to provide better tools to make judgments like that, or to assist people trying to make judgments about, what are the potential impacts in the area I'm working in too.
It always happens when we do a SilviCast episode. There's like something you and I talked about. I want to talk about it. And we kind of bypassed it in the conversation because we get excited and we jump ahead to other topics. So I'm just going to back up just a smidge. And that was something we talked about is as a forester, to deal with a problem, you need to recognize the problem. And one of the problems that we have is doing a good job of recognizing browse impacts. And what you and I had talked about earlier was, yeah, there's a bunch of different methods out there, and it's always challenging. Like, why is that challenging for us to get a handle on how bad the impacts are or aren't?
Right. Well, it's challenging because, like we talked about earlier, you have changing deer diet through the year, right? And so they're eating different things. You can miss what they're eating, especially if you're doing monitoring, say, only in the summer or only in the winter on deer browse. And so it's not really telling you the whole story when we do that. And so just given their really plastic diet, they're really able to adapt to a number of different conditions. And given that, it's time intensive to get out there and manage or count stems and say whether they've been browsed or not and gather that amount of data, it's really challenging for many agencies to kind of commit that level of manpower on the landscape to get out there and collect those data, especially more than once a year if you want to get the full picture. But I will mention we do make that effort in Wisconsin with our FRM program. I know you've had a SilviCast episode in the past talking about that monitoring program that we implemented here in Wisconsin in 2018, I believe, the Forest Regeneration Metric Program, where we have an army of technicians that go out throughout the most forested counties in our state every summer into regenerating stands and basically identify all the woody species in a plot within those stands and estimate the percent of those stems that have been browsed or not on the current annual growth. And so that's really time intensive. It's a huge investment by the agency, but I think what we're going to see from that is exactly what we're looking for, is starting to understand, what is the browse pressure here versus there and why. I think that's really the effort that's required, and we're doing that here, which is really exciting.
Is there a technique of all the different techniques out there to measure that browse impact that's better? One's better than the other. In Wisconsin, we use, the browse severity count of browsable stems, but that's just one method. Is there one that's been determined that's better?
There have been a couple papers in recent years that I might actually send to you guys to put on the show notes afterwards that actually compare different methods. And they have different objectives in their comparisons to those different methods. So they come up with different answers on what's the best. And I think it's hard to answer that because there's a number of different monitoring techniques. They are all pretty good. Some are better than others. I don't know that there's a best because you have to consider what your goal is. And I think you can choose a best monitoring method for whatever your goal is. There's Avid springs to mind where there's repeated annual measurements on permanent plots of 25 plants of interest. That was developed out in New York. The 10 tallest method is another method where you repeatedly or you go out and you measure this 10 tallest plants within a plot and do that over and over again. Sentinel species is another where you actually plant things like red oak out there and you go back and remeasure them to see what the browsing pressure is. Twig age is another one. That's where you would actually count the bud scars back to understand how old the twig is. So there's a lot of different methods out there. I think what I see most often in the literature, though, is almost what we're doing with FRM. FRM's a little bit simpler, but more typically you would go out to a site and you would count the number of available twigs on a stem versus the browsed twigs on a stem. And that gives you a proportion of available to browsed, and you can use that to understand preferences and browse pressure. So that would be the more typical kind of way we measure browse pressure. But again, it's really time intensive. I mean, counting the number of available twigs on a stem can take a really long time. And if you're counting hundreds of stems within a plot.
Yeah, you're not going to do that on a normal cruise of a stand.
No. That would be something you do when you have like a really well-defined, I think, experimental design in a smaller area. But we get really close to that with the FRM program. We don't count the number of twigs that are available in browse, but we do an estimate to percent browsed on the species within the plot. And that's really cool.
Yeah, somewhere there's an FRM technician in the woods right now listening to this podcast going, thank God they didn't say avid.
Exactly. Exactly.
Yeah, and if you can send us that paper or papers, Amanda, that would be great. That's just something I think about, and I know foresters think about too, in making that assessment. Nothing's ever easy. What the heck?
I know.
Nope.
And I'm biased because, I work in Wisconsin. I love Wisconsin. I think the FRM program is great. But again, depending on your objectives or your goals, I mentioned just a few of many other types of like monitoring methods that can be used. There's many, many of them in existence that do just fine.
This has been a really, really good conversation. What do you guys think is next on the deer forest research? What's in that world? What do you guys think is next? And this could be a 3-hour conversation or maybe not, right? Because it depends on what time we have.
So I'll keep it brief and just give my 2 cents. The other thing that I considered before, as a career besides ecology or forest biology was history. I'm a fan of history. And if you look at the historic literature, right, going back really all the way to the 1930s, with Aldo Leopold or Richard Gerstle here in Pennsylvania, we have a really good handle on what the direct browse impacts on extant plant communities are, right? So there's dozens, hundreds of papers on what deer do to plant communities at different levels of abundance. So I think that's already very well established. There are interesting questions, I think, still to be asked with some of these more indirect or cascading effects, some of these legacy effects. So how have deer altered soils or soil microbial communities? How have deer altered the genetic structure of those plant populations, which we discussed earlier, went from being somewhat abundant to now pretty rare and isolated? How has browsing altered the forest soil seed banks, right? The seeds that are stored in the soil for the next disturbance decades from now, right? The next harvest or the next blowdown. Deer have an impact on that. So the deer browsing you observe today will have a ghost or a memory 20, 30, 50, 100 years downstream. So understanding a lot of these long-term legacies, I think is at least one pretty rich vein of research that could be tackled in the coming years.
I really share Alex's perspective on the future direction of this research. And I think a lot about what we just talked about is that we are really good, or we have a good idea of what's happening on these extant plant communities. We have these methods available to understand what the browse pressure is. But I think what we're starting to shift to is, okay, we can monitor it and kind of understand those browse impacts, but how do we overcome those challenges through silviculture? I think that's the next direction we go to. And I think interesting avenues within that direction are what Alex has talked about with his foodscapes and thinking at landscape scales, but also there are more smaller scale things we can think about, like associational effects. So when one plant grows close to another plant and one of those is more preferred than the other, does that less preferred species kind of take some of the pressure off the more preferred species? And things like that are really exciting to think about in terms of trying to overcome this challenge of deer impacts on the forests with our silvicultural methods that are available to us.
Yeah. And I'll add here just to close, we met through our work on climate adaptive forestry through a couple different projects on climate adaptive forestry. And I think another really rich area to explore is how does deer browsing affect not just the forest that we're managing today under sort of these traditional silviculture regimes, but how does browsing affect forest dynamics under climate change? And so on one of the projects that Amanda and I are working on, we're practicing and implementing assisted migration. This idea that we can perhaps buffer our forests from climate change by proactively planting the forests of the future today. So we can say, in this particular area, the climate is supposed to be this much hotter or this much drier or wetter. So where do we find that climate now? Let's find species or populations of species that we can then transplant to these forest communities in order to sort of prepare them for the impending change. Well, what happens there, right? So I think it's pretty interesting. If we were moving a plant species or even a population of a plant species to a new location, it's going to be under stress. It's going to be different soil communities, different suite of competitors, different associational effects, as Amanda just mentioned, and perhaps different browsing pressure. So do the old rules still apply, or do we have to practice a slightly different silviculture? And so that's one of the projects that Amanda and I work on. It's an experimental effort called the DREAM Project. And DREAM is an acronym for Desired Regeneration Through Assisted Migration. And it's an international project. We have colleagues in Quebec with a few study sites there. And then we're launching and implementing this work also in Wisconsin. It's really exciting. I think it's probably a topic for another podcast down the line, a future episode. But again, just thinking about how all of these things change now when you layer in that complexity of climate, of a changing climate, and silviculture that would be adapted to that changing climate.
That's actually exactly what I wanted to mention, Alex. So you did a perfect segue there. So just that whole overlap with our changing climate and how deer are going to play into that. So,
and even outside of the assisted migration, thinking of our like northern lake states, weather has been, been a limiting factor on deer. So climate change could come into play a role there. But you made me, when you were just saying that, Alex, it made me think if we have these changes because of those deer, it's going to limit there are going to be differences in the forest's ability to adapt to climate change, even without that assisted migration too, depending upon a lot of things. So yeah, had a lot more tentacles to it than I thought.
A lot of tentacles there, and that's one of the other projects that Amanda and I collaborate on is, under these changing climatic conditions, how does the actual composition of the herbivores or the browser community shift? Moose versus deer. Moose are increasingly under stress, perhaps declining in abundance where they're already fairly infrequent, and then ramping up deer densities as the climate becomes more favorable for them. So that landscape of herbivores or browsers might shift as well.
Amanda, Alex, my hope in this conversation is there's a lot of information there to think about and chew on, no pun intended. My hope is that foresters don't get frustrated like we don't know all the answers, but we are learning and our knowledge base is growing. And so I think this was a really great conversation to pull out those pieces of things that we have learned through that research and where we're going, and then to think about how does that translate into our strategies silviculturally in the field. And so I think you've given us foresters a lot to think about. So I really appreciate that. And I really appreciate your time here.
Yeah, fantastic conversation. I think everyone who listens to this is going to pull something out.
Great, thanks. It was really fun. And to the foresters, don't get frustrated. Don't throw in the towel yet. I think there's more to learn, and hopefully that more to learn is focused more on silvicultural techniques to help us overcome these challenges with deer.
Mm-hmm.
Great, Amanda. And Brad and Greg, thanks for the opportunity to speak on this podcast. I was looking forward to it, a bit nervous, but glad to do it. Glad to share what we've learned, and I'm always glad to interact with and chat with my friend and colleague Amanda, which you mentioned earlier. She's one of the scientists. What you call her, scientist supreme or something like that in the DNR.
We'll use that.
I mean, that's one of the best things about my job is really, or what I get the most satisfaction with is just meeting people and chatting with folks like you, like Brad and Greg, and then working with bright young folks like Amanda. It's really rewarding.
Yeah. Great conversation, both of you. Thank you much. And I'm sure we'll be talking again.
Cheers.
Thank you.
Well, it's that time again, folks. Brad, what's your word this week for Silvictionary?
Okay, so actually this is going to be an acronym, and it is CMT. And you know what that stands for?
Isn't that a band?
Yeah, well, no, it was a song, right? CMT, Dynamite, right? AC/DC. It was good stuff. All right, no, it wasn't that. Today's words based on our acronym is a culturally modified tree.
Oh, okay. I think I know what that is. I've never heard of it as a formal word and definition, CMT.
Yep. So oftentimes, foresters on the West Coast, whoever our listeners out, you guys are probably familiar with this. And here in the East, we see it too. But culturally modified are any tree that's been cut or shaped or scarred by humans for any purpose. And so a lot of times here in North America, we think of them with indigenous land managers basically using it for lots of different reasons. The cool thing is that they're still present all over both the eastern and western United States.
So like here in the Lake States, I would be familiar with maybe marker trees that were designed to mark trails, right?
Yep.
Would that be an example? Or like resin trees along lakes that were used to collect resin off of?
That's right. And so to me, what's really cool about it is it reinforces the idea that indigenous land managers were managing, and they had tools that we can still see today that they were using. So you mentioned the trees where they almost cut a quote unquote window into the tree, and they can collect resin in those areas that they can use for lots of different purposes. And you mentioned also the trail marking trees, which indicate that something is going to be in a particular direction. So it's basically leading a passerby to a particular place for a particular purpose. So what's cool about it is I think there's a danger oftentimes we might look at those trees as, at least here in the eastern United States, as really poorly formed, maybe some of the trees that we would want to take out of a stand first. After reading a lot about this, it makes me think we should really make sure we're not taking or we're not impacting a culturally modified tree. Just don't assume that it's just a poor tree for no reason.
Well, okay. I learned a new term today, so thank you very much.
Well, thanks again for listening to today's episode of SilviCast. If you have ideas for future episodes or a question for the Dropbox, please let us know. You can reach us at UW Stevens Point's Wisconsin Forestry Center by emailing wfc@uwsp.edu. Feel free to include a sound file of your question or a comment if you like. Remember, we learn best when we wrestle with questions, so keep them coming.
And take care, everyone. And as always, thanks to our team, Susan Barrett, our editor-in-chief, Joe Rogers, our IT master, theme music by Paul Frater, and of course, UW Stevens Point's Wisconsin Forestry Center.